In this problem, we will find all the permutations of an array. For example, if the input is this array 1, 2, 3, then we want to find all the ways in which the elements in the array can be arranged. So the output is this list of arrays. So we have 1, 2, 3, 2, 1, 3, 2, 3, 1, and so on. So totally we have 6 values. If you remember your math from high school, you'll know that if there are 3 elements in the array, it can be arranged in 3 times 2 times 1, so equal to 6 times. So given an array, it can be arranged in given an array of size n, it can be arranged in n factorial ways. So we want to enumerate all the n factorial ways in which the elements in the array can be arranged. That's the problem. um, as usual, we will solve it using recursion. I will pause the video and give you a chance to try to solve the problem on your own. Okay, so we will apply our recursion principle. Let's take this example itself, 1, 2, and 3. Now how I will solve it is, I will assume that I have found all the permutations for this smaller subproblem. So 2 comma 3 is the smaller subproblem. If this is the input, then the output is 2 3 and then 3 2. There are only two ways in which uh, these two values can be arranged. And now I don't really care how I'm going to solve the subproblem. I'll just assume that I have solved it. So this is the most important step in recursion: identifying the subproblem and just assuming that it will be solved. So now that I've solved this subproblem, how will I solve my original problem? That's the question. For that, how we'll solve it is, we'll take each one of the arrangements in our smaller subproblem. Let's take 2 comma 3, and all we have to do is add 1 to this array. But this 1 can be added in different positions. It can either be added in the first, or it can be added in between 2 and 3, or it can be added in the last position. So if 1 is added in the first position, we get 1 2 3, and if 1 is added in the second position, we get 2 1 3, and finally if 1 is added in the last position, we get 2 3 1. So these are the three permutations that we got from this previous subproblem permutation. And remember that we also have this other permutation where 3 comes before 2, and we apply the same process. So from 3 comma 2, if we add 1 at the beginning, we get 1 3 2. If we add it at in the middle, we get 3 1 2, and finally we get 3 2 1. So now we have all the 6 permutations, and we have solved the problem. That's it, right? So this is the overall logic. So now we have to translate it into code. Once again, I will encourage you to solve it on your own and pause the video. Okay. In this particular problem, you can see that combining the results from the individual subproblem, this was the interesting part, right? We only had one subproblem. For to solve this problem, we only had to solve one subproblem, but the way in which we generated all the permutations, that was the interesting part. That's where we did a lot of logic. So that's going to be the fun part. Let's write the overall code. And of course, we have the base case as well. The base case, as usual, it's quite simple. If the length of the array is 1, we just directly return that particular value in a array. That's it. Okay, so that's a base case, and we also discussed all the other steps. Let's write the code. So I call this function as permutations, which takes an array. If the length of the array is 1, we just return this array within an array. This is the important part. We only have one permutation, but that permutation itself must be present in an array. Okay, now we will solve the general case. This is the base case. So the cool thing about recursion is that we don't have to worry about each subproblem. If we have the logic for the base case and the general case, everything will take care of itself, right? So now we'll solve the general case. Like I mentioned previously, this is like the most important part of our thinking, where we come up with a proper general case which will work for all the it will work irrespective of which position of our program we are in. Okay, all right. Now, like we saw here, if our problem is 1, 2, 3, we need to split it into two pieces, 1 and then 2, 3. So let's go ahead and do that. So we'll say let first and then rest equal to this array. This is just a JavaScript feature to split an array into the first value and the remaining values. Let's just print it to see how it works. So we have the first value and the remaining values called rest in a array. And next step is we need to solve our subproblem. So we'll call the permutations function with rest as the input. And the output will be all the permutations of 2, 3. So we have, let's call it subproblem permutations or subpermutations for short. And now what we have to do is we have to iterate through every permutation and sub permutations, and within that we need to insert these first number 1 in different positions. So what we'll do is we'll say let permutation of sub permutations. So the permutation could be like 2 3 or 3 2. So usually what I would do when solving the problem for the first time is I will imagine what the actual values will be when writing the code. So the permutation could be either one of these values. And now the value 1 must be inserted in all these positions. So for that what I'll do is I will create a variable p which starts from 0 and goes until the length of each sub permutation. So p less than equal to sub permutations dot length p plus plus. Here we are using equal less than equal to rather than just less than because this value 1 can be added at the end as well. So we need to consider the final index of our sub permutation. And now we'll break our sub permutation into two pieces. So we'll say let left equal to permutation dot slice 0, 3. So here we are taking all the values until p to the left, and then we create another array right which has all the values to the right of p. So that's how we'll do it. So one example value could be let's say 2 and 3. So if left is 2 and right is 3, then the actual permutation we will eventually get is 2, 1, 3. So we need to inject the first value in between these two arrays. So let's do that. Let's call that array as perm. So we have to take the left array and then add this element first to that array, and then once again concatenate this array with the right array. So finally we get the desired permutation, and finally we will append it to our list of permutations. So let's call our result as all permutations and append this permutation to this list. That's it. That's the logic. We'll return the all permutations. Let's see if it works. So it does. We got all the 6 values. To test it, we can also first test it with an array of size 1. So we get an output of size 1 as well. Here we get an output of size 2 and then 6 and then finally 24. So if you want to check whether it works, you can use this Unix command. Check the number of lines. We should have gotten 24. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Oh no! You've gone wrong somewhere. Let's see. So I took some time to debug this problem. The problem was that I had to use permutation.length rather than subpermutations.length. So the overall logic is right. Let's run the code with this input. So we say node perm.js and we get all the permutations. Let's check the number of lines. So we get 24 uh, and the output seems to be correct. So this ends our series of videos on recursion. Like we saw, different problems were interesting in different parts of coming up with a solution. So in some problems, combining the results of the individual subproblem, that was more challenging, like in this case. And in some problems, identifying the subproblems, that was more difficult. And in some problems, of course, the entire uh, code itself was easy, but coming up with the logic itself was the challenging part. So hopefully now you have a idea on how to solve recursion. Like I've repeated multiple times, the most important thing is to come up with the base case, come up with the general case, and then trust that the general case will work until we reach the base case, and not to worry too much about how each subproblem will work. So assume that you're a manager and you have like bunch of very trustworthy employees and you have assigned the work to them and you just know that they will do the work for you. Cool. That's about it.